Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher, and happy Diwali everyone, happy Diwali, and may God bring all the happiness, may all your dreams come true on this Diwali, and your next year you celebrate your Diwali in your dream college, right? That's my wish for you, that next year Diwali is going to be maybe away from home in your dream college. So celebrate this Diwali. I know some of you are celebrating Diwali on 31st of October. Some of you are celebrating Diwali today, right? So, yes everyone, thank you so much. Thank you so much. So guys, today we are going to, in this Diwali, we are going to cover a very important chapter, that is aldehyde, ketones and carboxylic acid. It's a very important chapter. It is going to give you around 3 to 4 questions easily, right? It's that much of important chapter, right? So this Diwali we have this gift for you, right? Okay, so thank you, wish you the same. Thank you students. Abhishek, thank you. Okay, so guys, shall we start the lecture? Yes. Shall we start the session? Shall we start the lecture? Everybody in the chat box, everybody in the chat box. Yes. So, now what I have seen that some of you are being very lazy in commenting, right? So, only these many comments I can see. Though the comments are really beautiful. Thank you so much Roshni, Madhumati, Rajput, Henderson and Pradeep. Thank you so much for your lovely comments. Other students also, don't be that much lazy. If I can stand here for you for 5 to 6 hours, you can at least give appreciation for just 1 minute. Take just 1 minute to write something for your teacher who is doing so much for you, right? Okay. Entire chapter, ma'am? Yes. Today we are going to complete the entire chapter. Okay? Yes, Diwali is about fun. I know that. Festive season is about fun. I know that. But you know what? When you have Diwali and you have also one very important exam nearby, so I don't think so that you should, waste your full day. Like, I want to celebrate Diwali. You should also revise things. You should also practice things, right? Okay. Chal. Just give me a minute. Let me change my pen. Yes. Okay. Okay, chalo. Now, let us see and start the lecture without wasting any time, right? We are going to do NCERT line by line for aldehyde, ketones and carboxylic acid. Each line of NCERT we are going to see. So, let me take my specs and wear my spectacles because that is important, right? And let us start the session. Yes, the chat should be filled with green hearts. Happy Diwali, Preetam, Swati, Surya, Kareen, Umesh, Tanuja, Sabari, Arts, Banot. Happy Diwali, Bala. Happy Diwali, everyone. So, let us start this session without wasting any further time. Now, what exactly we are talking about? Aldehyde, ketones and carboxylic acid, right? So, what are basically these aldehydes? Aldehydes are when you have an alkyl group, right? When you have an alkyl group and to this you have the attachment of C double bond OH. When you have an alkyl group, to this you have carbonyl, that is C double bond O. Then again, instead of this H, you have one alkyl chain, that is R dash. Third is when you have R, C double bond O, but then instead of this H, you have OH. This is your aldehyde, right? This is your aldehyde. Wait a minute. This is your aldehyde. This is ketone. This is ketone. And this is carboxylic acid. Carboxylic acid. As you can see that one thing is common between all of them. This is C double bond O, C double bond O, C double bond O. That is why we have a complete dedicated chapter on this, right, where we are basically going to study about carbonyl compounds, right? What is this called? This is called carbonyl group. This thing is called carbonyl group, okay? This is called carbonyl group. Carbonyl group. Okay. So today we are going to talk about carbonyl compounds only. So let us start this. Now in the first 2 pages they have given us the basically the applications of where we have acid, aldehyde, ketones and carboxylic acid. All the applications they have given in the first part. So in the previous unit you have studied all the different units. Now they are saying that this bond is called, C double bond is called carbonyl group that I told you, which is one of the most important functional groups in the organic chemistry, right? Because these things are very important for us. We use this in our daily life, right? In aldehyde, the carbonyl group is bonded to carbon and hydrogen, right? And in carbonyl group, in which carbonyl is bonded to this, they had told you about basically what is aldehyde, what is ketone, what is carboxylic acid, that I have told you here, right? Same thing in the paragraph form they have told you. Now, they are talking about the derivatives of carboxylic acid. For example, this I am saying is the carboxylic acid. Now they are saying that if the carbonyl compound in which carbon of the carbonyl group is bonded to carbon or hydrogen and oxygen of the hydroxyl moiety, that means this thing they are talking about. This thing they are talking about, that if your carbonyl is bonded to OH bond here, right, are known as carboxylic acid, while in compounds where carbon is attached to carbon or hydrogen and nitrogen, for example, they are saying that, for example, this carbon is attached to nitrogen like NH3. This group will be NH2. This group will be called as amide group. These are called the derivatives of carboxylic acid, right? For example, you have the attachment of any halogen here. This is called acid halide group, right? For example, you have the attachment of, instead of OH, you have the attachment of OR. What is R? R is the alkyl chain, right? Then this will be called as the ester, right? These are the carboxylic acid. These are the derivatives of carboxylic acid, and both are important for you, right? Okay, we are also going to see today how to derive different derivatives of carboxylic acid also, right? Amide we will see in detail in the next chapter, that is your amines, right? Okay, now next thing is, now they have given you a full-fledged thing here, that this C double bond H is called aldehyde. C double bond R is called, where you have both the alkyl chain next to carbonyl, that is called ketone. When you have carboxylic acid, to this R dash, instead of this R dash you have OH, right? If you talk about, you have X here, that is called acyl halide or acid halide. If you have NH2 here, that is called amide, right? So these are the different derivatives. Now we will talk about some very important common names, right? Very important common names. Directly I am telling you that, for example, they are saying to this benzene you have 3 groups attachment. One is CHO, one is OH, and one is OCH3. That is called vanillin. Vanillin, right? The name is called vanillin. Vanilla ice cream. Have you ever eaten vanilla ice cream? Vanillin. Right? Now this is salicylaldehyde. Now this is your OH and CHO. Salicylaldehyde I told you in the last lecture also. How to prepare salicylaldehyde from phenol. That we have already done. Now this is cinnamaldehyde. Right? So this is CH double bond CH-CHO. Right? This has been asked also. Right? This is important. This has been asked also. That is called cinnamaldehyde. Right? Okay. So these are very important common names. Common names, you have to remember only those common names that are mentioned in your NCERT. Apart from NCERT, you don't have to remember anything. Only mentioned in your NCERT, you have to remember those common names, right? They are, now let us see the uses here. They are used in food products, pharmaceuticals, to add flavors, because they have aroma, right? This has vanillin, aroma, right? Vanilla ice cream, right? Cinnamon, right? Aroma, right? So they have different kind of aroma, right? Esters are aromatic. Esters also have a very good aroma, right? So some of these families are manufactured to for use as solvents. Like acetone is a very good solvent. You have seen this in Finkelstein reaction as well. If you remember Finkelstein reaction, there what we did, we used NaI with acetone. NaI with acetone. So acetone is basically used as a solvent here, right? Okay, and for preparing materials like adhesives, paints, resins, perfumes, plastics, fabrics, in all of this we use these organic compounds, right? We use these organic compounds in all these cases. Now let us firstly start. We will see what we are going to discuss in full chapter. We are going to discuss preparation and properties. Properties we are going to discuss physical and chemical. This is the thing that we are doing from past 2 chapters. We are discussing preparation, then we are discussing the physical and chemical properties. Out of this, physical properties so very simple, but reactions are there in chemical properties and preparation. So firstly we will see the preparation of aldehyde and ketones. Then we will see the chemical and physical properties of aldehyde and ketones. So let us start this. Very, very important naming reactions you will see from this chapter. Very important naming reactions. Okay. Chalo. Now, talking about aldehyde and ketones here, so they have just talked about the common names. So let us discuss about the common names. So common names of aldehyde and ketones, we will see that how their common name and how is their IUPAC name differentiate. Now some of the very, very important common name is, if you talk about CH3CHO, that is called acetaldehyde. Okay, the name is called acetaldehyde. Okay, if I talk about CH3COOH, that is called acetic acid. Acetic acid, right? If you talk about on the benzene, you have CHO. Firstly, so they are just talking about aldehyde, no? Yes, they are talking just about aldehyde, so let us focus only on aldehyde. Aldehyde, some of the very important common names are, this is called acetaldehyde. When you have CH3CHO, this has been used so many times. In the products they will give you, or in the reactant they will give you that you have 2 molecules of acetaldehyde, you have 1 molecule of acetaldehyde. You should know what is the structure of acetaldehyde, right? Next is benzaldehyde. When on the benzene you have CHO, that is called benzaldehyde. Now this is called beta bromobutyryl aldehyde. Now basically what is this? Now how many carbons you have? 1, 2, 3, 4. That is why here you have butyryl aldehyde, right? Butyryl aldehyde. Okay. And what about beta bromo? Now we know that to this carbonyl, the first carbon attached is called alpha, the second is called beta, the third is called gamma. So bromo is attached on the beta position, so it is called beta bromobutyryl aldehyde. Okay, again a very, very important name, right? Next is the common names of ketones. Let us see the common names of ketones here. Ketones, very important. First is your acetone. Remember one thing. When you talk about acetaldehyde or acetic acid, you have 2 carbons. Acetaldehyde and acetic acid has 2 carbons. But when we talk about ketone, it has 3 carbons, right? So it is acetone. It has 3 carbons. Now what about acetophenone? Acetophenone is, this is also very important, right? You will see acetophenone so many times. What is acetophenone? On one side you have benzene ring, on other side you have CH3, right? So basically you have just substituted in place of one CH3, you have substituted one phenyl group. That is called acetophenone, right? What is propiophenone? In propiophenone, instead of this CH3, you have CH2CH3. That is called propiophenone. Okay, what is benzophenone? Again, very, very important. This also you will see so many times, right? Benzophenone is when both sides you have phenyl groups. That is benzene ring, right? This side also, this side also. That is called benzophenone, right? Because we are taking one as the main chain, The other we are taking as the side chain, right? So that is benzophenone, right? So these are some of the very, very important common names. Now let us talk about the IUPAC names here, right? Let us talk about the IUPAC name. IUPAC name, I have completed IUPAC name in details, right? So you can watch that lecture also. Here I am doing just revision what is mentioned in your NCERT, right? Otherwise, a full-fledged lecture of IUPAC naming of all the compounds I have already done, right? Now, this is called ethanol. Now, what is ethanol? 1, 2, it has 2 compounds. So, group is aldehyde. So, it will be acid. What is this? Number of carbon. Instead of ethane, you will just erase this E and apply al here, ethanol, right? Same is with this one. Here you have 1, 2, 3, 4, 5, 6, 7, right? So you can say that on the third position you have methyl, on the fourth position you have bromo, and this is called heptanol. 4 bromo, 3 methyl heptanol. Now, what about this one? Here this is 1, 2, 3, 4, 5. So here 3 methyl cyclopentanone, because first position you have one. This is a ketone. This side also you have carbon, that side also you have carbon, right? What about this one? Here you have, this is, that is mentioned outside, no? So it will be, it is directly attached to ring. Now, I told you one thing when we were doing IUPAC naming. When your CHO group, the carbon containing group, whether it's COH, whether it's a carboxylic acid group or it is aldehyde group, if it is outside the cyclic ring, then instead of al, you will use carbaldehyde. This is the suffix that you will use here, right? So this will be cyclohexane carbaldehyde, right? And E is only cancelled. Here you will say, ma'am, why we have not cancelled E of this? E is only cancelled when you have because after this you have A or I or O or U or Y. Only then we will cancel this E, otherwise this E will not be cancelled, because here after hexane you had C. You had C here. So that is why this E was not cancelled here, right? What about this one? Here you have, this is 1, 2, 3, 4, 5, right? So it will be pent 2-ene, because on second position you have ene, double bond, ene, al, right? Ene, pentene. Now if you want to place al here, then E will be cancelled, because after E, if you have A, then E is cancelled. That is why it is pent 2-enal, right? What about this one? Here you have, this is 1, 2, 3 or 1, 2, 3, 4, 5, 6, right? So I will consider this as 1, 2, 3, right? I will take it as 1, 2, 3 because here this is outside, right? So this will become my 1-phenyl propane 1-one, right? So on the propane, first position you have one. So this will be propane 1-one, right? Okay. So these are some of the very, very important common names here. If you talk about this, very important. Here you have 2. Here we are talking about polyfunctional groups. Polyfunctional groups. So how many of you attended my lecture of polyfunctional groups? Right? How many of you have attempted my lecture of polyfunctional group? How many of you? Yes, Neha, Roshni, E will be cancelled, definitely. Banot. Have you attended my lecture of poly? Because that is a dedicated lecture where I have done polyfunctional group. So in polyfunctional group, exactly what you have. There is more than one type of functional group, right? For example, here you have aldehyde, and to this aldehyde, we have the presence of this ketone, right? Aldehyde and this ketone both are present, right? Now tell me which one will have more priority. Which one will have more priority? Which one will have more priority? Yes, everybody. Aldehyde will have more priority, right? Okay, I have already done the polyfunctional group, the priority order of polyfunctional group, right? So that is not what we are focusing on this chapter. This is a revision because that is mentioned in your NCERT. That is why I'm just revising that thing here, right? Okay, chalo. Yes. Keep link in the description. Okay. Nirmala, I will ask the team. Now the team is on holiday, right, because of Diwali, but I will try to do it myself or ask the team about it, right? Okay, that will be updated by Monday. Okay, yes. Polyfunctional group lecture, IUPAC naming lecture. Now, this is 3-oxo. Why? Because this is my priority group. So, this will be 1, 2, 3, 4, 5. Now, whenever your ketonic group is in the chain, right? It is in the chain. Now, my ketonic group is in the chain. That is why I will write 3-oxo pent. Otherwise, this is same. 1, 2, 3, 4, 5. Pentanol. But now my secondary group will become the substituent. And whenever ketone is in the chain, that is called oxo, right? So here it is called as oxo, right? What about this one here? Here it is just one functional group, so it will be 1, 2, 3, 4, right? So it is 2, 4 on second and third position you have dimethyl, right? Let me see. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5. Yes, now it is okay. So now it is second and fourth position you have dimethyl. Second and fourth position you have dimethyl. 2, 4 dimethyl. 2 methyls you have. These are the substituents. Now there is no competition between, oh my god, I am ketone, you are aldehyde. No competition, right? This is ketone. It's like I am only the king here, right? So here it will be 2, 4 dimethyl pentene 3-one. Right, this is pentene and this third position is your one. 2, 4 dimethyl pentene 3-one. Now, next is this one. Here you have 1, 2, 3. Very important. Very important. Right? Now, here, students, what you will think? You will think that, ma'am, it should be 1, 2, 3. It should be, ma'am, like this. That on the first, second and third position, or ma'am, should we take it like this? Should we, ma'am, consider it like this? Because longest chain, ma'am, you are saying, now we have to consider, right? So in this way, what will happen? These are the members of same family, CHO, CHO, CHO. For example, you and your siblings, right? Your parents give respect to, your parents give attention to your other 2 siblings, but not you. Then you will feel very sad about it. You will be like, why this is happening to me, right? You will be very sad about it. Now, it's now very important for you to understand that if you have CHO, CHO, CHO group, all 3 either should be included in the longest chain or exclude all of them from the longest chain. It's not like you have to accept one thing in the longest chain, other 2 should not be in the longest chain. That is not how organic chemistry IUPAC naming works, right? You have to either take all of them in the longest chain. Is there any criteria where I can take all of them in the longest chain? Anywhere I can take all of them in the longest chain? Not possible for me. Not possible for me, right? 1, 2, 3, 4. Now this is excluded. 1, 2, 3, 4, 5. Now this is excluded. So it's not possible for me to take all of them in the longest chain. That is why I will exclude all of them in the longest chain. This is 1, 2, 3. This is 1, 2, 3. So now this is your substituent, this is your substituent, this is your substituent, and mark my words here, write it down here, write it down here. When you use carbaldehyde, carbaldehyde or carboxylic acid, you use it when you have symmetry, or second thing where you use it in ring. So now in ring, we have already seen that when CHO was connected to this ring, we used carbaldehyde. But now because of this symmetry here, which symmetry, which kind of symmetry? You had C, 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 and now CHO is bonded here, CHO is bonded here, CHO is bonded here. That is the reason, because of this symmetry, we will use carbaldehyde here. Very, very important, right? That is why we used carbaldehyde here. So you can write propane, because this chain is propane. On the first, second and third position, you have tricar, 3 carbs, no? So that is why tricarbaldehydes you have, right? Okay, so this is this session is enough for NEET? Yes, definitely. That is because I am going to include everything here, right? Okay, so propane 1, 2, 3 tricarbaldehyde is your correct answer in this way, right? Okay, now what about this one? Here, why I have used carbaldehyde? Can you tell me the reason? Anybody in the class who can tell me the reason why I have used carbaldehyde? Why I have not used why I have not used anything else? The reason that I have used carbaldehyde here is because this CHO is directly connected to a ring. This CHO is, here we use carbaldehyde because of symmetry. Because of symmetry, they have also mentioned here, to give identical treatment to all aldehydic groups, the compound is named as shown above, right? So now here I have 1, 2, 3, 4, 5, 6. So on the 4th position you have nitro, it is 4-nitro benzene carbaldehyde. Either so you can use this thing, or you can also use, because this whole thing, what is the name of this thing? What is the name of this full thing? This is called benzaldehyde. This is called benzaldehyde. We have already seen it here. This is called, where it is, yes. Here it is now. We have used benzaldehyde. Now, very important thing that might come in your mind, that ma'am, this was CHO, right? You are saying that ma'am, whenever CHO is directly linked to any benzene ring, that should be called as carbaldehyde. Then ma'am, why we have not written it as benzene carbaldehyde? Because ma'am, this rule is also applied here, no? Here CHO is also directly linked to this benzene ring. Then I am saying, guys, you are not wrong. You are right. Technically, according to IUPAC name, the name should be benzene carbaldehyde, not benz carbaldehyde. But it's like that situation where my name is Diksha, but you have made me famous by Dosa ma'am. It's not like on my Aadhaar card it is written Dosa ma'am. It's not like in my Aadhaar card it is written Chintu ma'am. But I know when you think about me, when you think about Diksha ma'am, you think about Dosa ma'am. You don't think about Diksha ma'am. You think about Dosa ma'am, right? So basically, the actual name is benzene carbaldehyde only, but it has become famous by benzaldehyde. That is why you will see in your exam we have used benzaldehyde only. Same is with benzoic acid, same is with other things, right? Okay, same is with benzamide, right? Everything is same only, right? So they have become famous by some other name. That is why IUPAC said that, okay, we will accept this thing. Now, one very important thing here, also write down this thing here. If you talk about ketone, if it is included or if it is not included. Now, if ketone is included in the parent chain, if it is not included in the parent chain, if it is excluded in the parent chain, if it is included in the parent chain, it will be called as oxo or keto, right? If it is excluded from the parent chain, right? Ketone can never be excluded, but aldehyde can be excluded, right? Aldehyde. If aldehyde is included in the parent chain, that is called oxo. If it is excluded from the parent chain, that is called formyl, right? That is called formyl. Now, I'll tell you one, I'll give you one question for that. For example, you have this thing. Now, here I am saying that it is behaving as substituent. When it is behaving as substituent, then I am saying this thing. Now, it is this. Now we know that who is the king? Definitely COH, carboxylic acid is the king, right? So 1, 2, 3, 4, 5. Now aldehyde is the substituent here. This is the main group. So that is why here it will be written as pent. Now firstly let us fill this name for this substituent. Now as CHO is not included, or you can just write it is excluded. It is excluded. So it will be named as not oxo, but it will be named as formyl. So answer will be 4-formyl. Everybody try to answer it. 4-formyl. 4-formyl because it is excluded. Then it will be pentane because it has 5 carbons in the parent chain. Now for COH the name is oic acid. When it is behaving as a main group, then it is oic acid. So instead of this E, we will write 1 oic acid. 1 oic acid. Okay. Yes. Nirmala, I have already done that in haloalkanes, haloarenes, right? You can watch that lecture. Very good. Pentanoic acid. Very good, very good, very good. That is mentioned in the list. You can see the live session that is mentioned when I am taking amines, when I am taking electrochemistry. Then we will be left with just one chapter, that is biomolecules. So basically 3 chapters we are left with now, right? So now let us see the naming here. Let us see the naming here. This is for the common names are very important. I'll mention some of the very important common names. HCHO is called formaldehyde. CH3CHO is called acetaldehyde, right? If you talk about common name, ma'am, is there any logic behind that? No, there is very rarely you will see logic behind common names, right? Usually they are represented because of some of their properties or some of the structure, right? That is why, that is how common names are named. For example, if a kid is very, very clever, right? If a kid is very, very stubborn, right? Or if a kid is very, very cute and very fatty kind of kid, like Golu Molu kind of kid, we will call that kid as Golu, right? Okay, we name some of the kid as Chintu, Mintu, Shintu, Sunny, Honey, Money, right? These kind of names we give to the kids. There is no logic behind that name, right? So similarly, there is no logic behind this. But with IUPAC naming, there is proper logic. This I have already told you how we will do that, right? Now, this, when you have CH3, CH and 2 methyl groups are attached to it, that means they are talking about when you have CH, when you have CH, this is CHO, this is CH3 and this is CH3. Now I told you one thing about this, then when to one carbon you have 2 methyl groups attached, right? That group is called iso group, right? So that is why we have written here that this is iso butyryl aldehyde, right? Next is, this is your ring. To this CHO is directly attached, that is why it is carbaldehyde, right? So it is gamma. Why gamma? Because if you talk about numbering in case of common names, this is alpha, beta, gamma. So this will be alpha, beta and this is your gamma. So it is gamma methyl cyclohexane carbaldehyde. What about this one? In this case, you have which thing? In this case, what you have? In this case, you have this thing. In this case, you have, this is your CH3, this is CH, this is OCH3, this is CHO. Now, as you can see, there are 2 functional groups present here, and this group is called the methoxy group. That is why we have written alpha. Alpha, why? Because this is on the alpha position, this is the beta position. On the alpha position, you have methoxy group, that is OCH3 group. That is why alpha methoxy propio. Now, ma'am, why this propio, ma'am? Reason, ma'am, propioaldehyde. Now, let us see what was propioaldehyde, right? What is the symbol of propioaldehyde? Propiophenol. Propio is basically this thing, right? So, basically, this thing is called propio, right? This thing is called aceto. This thing is called aceto, right? So same thing we are applying here, that what is propio? Propio is this thing. When you have CH3, CH and then CHO, that is called propio, right? Propioaldehyde. 3 carbons basically, right? 3 carbons, that is called propio. right? And now what is velar aldehyde? Like what is velar aldehyde? When you have 1, 2, 3, 4, 5, total 5 carbon name aldehyde you have. Then if you have on the vinylic position, this is the vinylic position. Very, again, this is also very, very important. This is your PYQ of NEET. This is your PYQ of NEET. Acrolein. Acrolein is your PYQ of NEET, right? I forgot which year, I think 2015 or 16, I don't remember that. But it is a PYQ of your NEET where they have asked you some reaction, and in the product side they have given what will be the product, right? I think something like that only, that A, B, C, D, one of the option is acrolein, right? So here this is your PYQ only, right? So why, what exactly is this? In this your C double bond O and CHO group is directly connected to that. That is called acrolein group. That is called acrolein group, right? Next is very important. If you have CHO group, right, next to each other in a benzene ring, that is called phthalaldehyde, right? Then we will also study phthalic acid. We will also study phthalamide. Wait a minute, phthalamide, right? Yes, names are a little bit twisting, right? So phthal means when you have 2 carbon containing functional groups on that benzene ring and they are next to each other, that is called phthal. And because this is aldehyde, that is why it is called phthalaldehyde, right? Now, if to this group, right, where CHO group is directly attached, this is called benzaldehyde, right? And to the 1, 2, 3rd position you have bromo, right? Now, if you talk about common names, if this is your any group X, right? Any group I am taking, any group you take, right? Main group. To this, with respect to this group, this is called ortho, this is called ortho, this is called para, this is called meta, this is called meta, and this is called para, right? These are the things. Now, why we have written para here? Because to this is para, this is ortho, and this is meta. So it is meta bromobenzaldehyde, right? Okay, understood? Yes. Yes, next lecture is going to be electrochemistry only, Madan. Yes, students, tell me. Let us do the numbering further here, right? Then you have, next is, let's talk about ketones here, right? With ketones, they have given you, trust me on that, all the common names mentioned in your NCERT tables. You should remember that if you really want to get 180 out of 180 in chemistry. Otherwise, I can't guarantee that, right? If you're like, ma'am, I want to score full marks in chemistry, then you have to go through all these names, right? Then you also have to know the common names, the IUPAC name. IUPAC name all of you can do. But common names are very important because either you know common name or you don't know common name, right? If you have never seen it, you can't predict what is the common name, right? So, here it is very simple that on one side you have methyl, on the other side you have normal chain where you have 3 carbons. So, it is methyl N-propyl ketone, right? So, 2 chains to this C double bond O, you have 2 chains. So, you will just write 2 chains and after that you will write ketone, right? That is the common name, right? If you talk about here, this is CO, this is CH, CH3. Now, this is very important, right? This is very, very important. This is C double bond O, this is C, this is C, this is CH3, this is CH3, this is also CH3, this is also CH3. So, this you have 1 CH, 1 CH. Now, this chain and this chain. To this carbon also you have 2 methyl group. To this carbon also you have 2 methyl group. So, both are your iso groups. Both are your iso groups. Because here also you have 3 carbons. So, it is isopropyl. This is also isopropyl. So, that is why the name is diisopropyl. Right? That is why the name is Diiso. I have told you already that whenever you have one carbon and two methyl groups are attached there, that group is called iso. And iso group, the starting is from propyl, right? The starting is from propyl. But when we talk about one carbon and you have three methyl groups, then that is called neo. Then that is called neo, right? Okay, neo, the starting is from pentyl, right? Neo-butyl does not exist. Now, next is isopropyl ketone. This also we have done. Now to this double bond, right? Ketonic group is there. Now, if you mark this one, this is called alpha, right? Alpha. So, on alpha position, you have methyl, if I am doing the common name, right? IUPAC naming, we have already done. Again, I am telling you, right? So, alpha, common naming, we haven't done, right? But we have done IUPAC naming, right? So, this is alpha methyl. Now, this whole is called cyclohexane. But to cancel this E, hexane, cancel this E and you will have this O, right? So, it will be hexanone, right? Now, next is when you have C. Now, again, this is important. This is important. As it is, you should know the name. As it is, you should know the name. Mesithyl oxide. This is also asked to you, right? Mesithyl oxide. This is also your PYQ only. I am writing it here, right? I forgot whether it's a PYQ of JEE or NEET, but yes, it's somewhere I have seen this in PYQs, right? So, this is your mesithyl oxide. This name is very, very important. Very, very important, right? So, this, what you have to this CO, you have one side you have CH3 and to other side you have CH double bond C, and then to that carbon you have two CH3s. That is called mesithyl oxide. Very, very important name. Okay? Okay, students? Yes, everybody. Now tell me, any problem here? Any problem here? Any problem here? Any problem? Now let us see the structures of carbonyl group, right? Structural aspects of carbonyl. Now, acha, tell me one thing. If you talk about this thing here, if you talk about, because you know all the reactions are very interesting. Firstly, we will see the preparation, that is so not very interesting. But I will tell you the properties, the chemical properties of aldehyde and ketones are very important. Very important, and you will definitely see a question from there. I can guarantee you that. Aldol condensation, cross aldol, Cannies RO, right? Then you talk about these reaction with nitrogen, NH2 containing compounds. Directly reaction of aldehyde, very important. Semi-carbazide, what is oxime, all of these things, how they will be formed, right? Then the test of carbonyl group, very, very important. Now we are going to start the very important thing of this chapter, right? So firstly, let us we should understand the properties of this carbonyl group, right? So this carbonyl group, we know that this is carbon is less electronegative, this is partially positive, and this is your partially negative, right? That is why what will happen, we know that in a bond, when you have one sigma and one pi bond, this is sigma, this is pi bond, we know that these pi bonds electrons are loosely held to each other. They are very loosely held, they have sideways overlapping. That is why in all the reactions what you will see, these pi electrons will jump on this oxygen, and in the end what kind of thing you will have? You will have C, this is your positive and this is your O negative, and that is how the reactions will take place in case of carbonyl compounds, right? Now, the carbonyl carbon is sp2 hybridized. They are saying that this is sp2 hybridized, right? So let us talk about that. This is sp2 hybridized. Wait. Okay, I'll write it somewhere else, right? Now, if you talk about this thing here, how many sigma bonds it has? 3 sigma bonds. 3 sigma bonds means it is sp2 hybridized, right? Okay, carbon, that is sp2 hybridized from 3 sigma bonds. The 4th valence electron of carbon remains in its p orbital and form pi bond with the oxygen. This is the pi bond what it is forming with overlap with p orbital of oxygen. This is very important, that in the carbonyl group, pi bond is formed by overlapping of p orbital of carbon with, or you can say p pi bonding. P pi bonding. This pi bond between carbon and oxygen, pi bond is formed by the p pi bonding, because here in carbonyl, in chemical bonding, we have studied different types of bondings, right? P pi d pi p pi. So they can directly ask you in the carbonyl compound what kind of pi bonding they are showing. They are showing p pi overlapping, right? Not bonding, right here overlapping. P pi overlapping, right? My task is not to read this, my task is to tell you that from this what kind of question can be formed. In addition, the oxygen atom also has two non-bonding electrons. They are saying that this oxygen atom also has two lone pairs here, right? That is non-bonding electrons. The carbonyl carbon and three atoms attached to it lie in the same plane. Now they are basically telling you the repulsions, the structure, why the structure is like this. Firstly, they told you that this is sp2 hybridized. That is why it should be. We know that. Everybody in the chat box tell me. We have done this, right? When you have sp2 hybridization, the structure should be trigonal planar structure. Trigonal planar structure. This is the same thing that they are telling you, that the structure should be trigonal planar. The carbonyl carbon and the three atom attached to it lie in the same plane. The carbonyl carbon, right? And the three atom attached to it, this oxygen, this something carbon or this something carbon or whatever is attached here, depending upon it is aldehyde, ketone or carboxylic acid, right? It attached in the line the same plane. That is why we are saying this is a trigonal planar structure, and the pi electron cloud is above and below its plane. For example, this is your structure. Wait a minute, just give me a minute, Wait a minute. Yes. So now can you see this? Basically this kind of structure will be there for carbonyl compounds, right? So this is your, for example, C double bond O. I am taking this as C double bond O, right? I am taking this as C double bond O, right? This is my C double bond O. This is my hydrogen. This is my whatever chain is attached here and here, right? That I am taking by white atom. So this is in one plane. Now they are saying that in one plane, pi clouds will be over the plane and below the plane. Over here you will have pi clouds. That means the bonding of this C double bond O will be over here and here, right? They will, because there is sideways overlapping. Because of this overlapping, the pi electrons will be overlapped on this plane, right? Okay, so is above and below this plane, the bond angle are approximately 120 as expected from the trigonal planar geometry. Now they have shown you this thing here, that this is your CHO, right? This is your CHO. This is how it is looking like, right? This is how it is looking like. This is C double bond O. This is one alkyl chain here, right? One bond here. This is your C double bond O, right? This is the sigma bond. This thing I am showing is sigma bond. The pi bond is above and below. If this is the plane, it will be over here and below means over here, right? So it is above and below. If I am showing this, if I am showing it by this is my plane, this is my plane, this is my plane. It will be here, it will be here, right? So that's what they are telling, that it will make an angle of 120 degree as expected from the trigonal planar geometry, right? Okay, so now next thing, let us see. That was about the structure. What kind of structure for carbonyl compounds? It is having a trigonal planar geometry with 120 degree angle, where pi bonds are present above the plane and below the plane. But to this carbon of carbonyl and two side groups here and one CO bond here, that is sigma bond, all lie in the one plane, right? Now next is that I told you, because of the electronegativity this happened. The carbon oxygen double bond, right, is polarized. Why this is polarized? Because oxygen is more electronegative. Carbon is electrophilic Lewis acid. Carbonyl oxygen is a nucleophilic base. Now this is a tough, this is The simple way to understand this is that this will be electronegative, this is electropositive. Now what they are saying, electrophilic. Carbon is electrophilic. If something is positive, then it will get attracted towards negative. That means philic. Philic is love. So it has love towards something which has electron. And this is nucleophilic. Now this has love towards something which is having a positive charge. Now what is Lewis acid? Lewis acid is something which is electron deficient. As you can see, this is positive, that is why it is electron deficient. The one which is electron rich is called Lewis base, right? Okay. Now, because of this have substantial dipole moments, and because of this the high polarity of carbonyl group is explained on the basis of resonance involving neutral A and a dipolar structure as shown, right? Now what will happen? Because of this, what will happen? Pi bonds are not a very strong bond, right? Pi bond is a sideways overlapping. That is why electrons will jump here and you will have negative charge here and positive charge here, right? Okay. Okay, students. Okay, students. Yes, everybody. Yes, everybody. Shall we start the preparation now? Some of the preparations are repeated here. Some of the preparations are very new to you, right? So I will focus on those preparations which are new to you, not the one which we are repeating again and again, right? So the first is preparation of aldehyde and ketones. First we are talking about the aldehydes, right? Okay, ketones, somewhere you will see ketones, somewhere you will see aldehyde. So it just depends on what we are doing, what kind of reaction. So first is by oxidation of alcohols. I think, okay. Now, first is by oxidation of alcohols. So we know that when you oxidize alcohol with some mild oxidizing agent, you can have preparation of aldehyde and ketones. Have we done this in aldehyde? Have we done this in alcohol, phenols and ethers? Everybody in the chat box. We have done this. I'll give you a simple brief about it. When you had 1 degree alcohol, 2 degree alcohol, 3 degree alcohol. 1 degree, I am talking about mild, right? 1 degree on mild was converted to aldehyde. On strong, it was converted to carboxylic acid, right? Mild, it was converted to ketone. On strong, there was no reaction. And to 3 degree, there was eventually no reaction, right? And what about mild oxidizing agent? Mild oxidizing agent, can you name any of them? Mild oxidizing agents are like you have PCC, you have PDC, PCC, PDC, you have CrO3, CrO3. These are mild. What are strong? Strong are like KMNO4, right? Like K2Cr2O7. These are strong oxidizing agents, right? These are strong oxidizing agents, right? So here, as they are asking about aldehyde and ketone, so aldehyde will be prepared by 1 degree, ketone by 2 degree on the usage of mild oxidizing agent. Mild oxidizing agent. With strong, it will form carboxylic acid, and to this there will be no reaction, right? This we have done in the previous lecture, right? We have also done for the copper, right? That is our last lecture. We have done this. Next is dehydrohalogenation of alcohol, right? Now, for example, let us talk about any alcohol here. Any alcohol. This is your, this also we have done. For example, any alcohol, I am talking about this alcohol. Now, dehydrogenation. Yes, dehydrogenation, no. So, basically what will happen? For example, you have CH3, you have CH2. From this also you will take out hydrogen from here. That is how, and this also you will take out hydrogen. That is how you will have the formation of C double bond O. And now that is called your formation of aldehyde or ketones. For example, you have this thing. For example, you have this thing, C double bond, oh no, not C double bond O, you have COH, CH3, this is H, this is CH3. With some specific reagent, what will happen? This hydrogen will go from this side, hydrogen will go from this side. That is how you will have the formation of CH3, C double bond O, and this is your CH3, right? This hydrogen will go and this hydrogen will go, right? So now, what are these reagents that are used here? Reagents are important for you. This method is suitable for volatile alcoholic. Volatile alcohol and is of industrial application because directly we can prepare this. In this method, alcohol vapors are passed over heavy metal catalyst. The vapors of alcohols are passed over heavy metal catalyst like Ag and Cu. Primary and secondary alcohol give aldehyde and ketone. Always primary will give you, because here what you had? Here you had 2 degree alcohol. Here you had 2 degree alcohol. That is why it was giving us ketone. If you had 1 degree alcohol, that is like this. CH3, CH2, and this is COH. CH2OH. Right? To this what you will have? Take out hydrogens from here. 1 hydrogen and 1 hydrogen from here. What you will have? You will have the formation of, this is CH3, this is CH2, this is C, and this is H, this is C double bond. And this is the formation of aldehyde, right? Okay, and what they are using? They are using Ag. Right? Ag or copper, right? Ag or copper. Okay, understood this thing? Now, there is also a specific temperature that is mentioned here. That is your 573, 300 degrees Celsius basically, right? This also I have told you that we have done this before as well, right? Next is your from hydrocarbons. Now let us see from hydrocarbons how you can prepare this. From hydrocarbons they are saying, first is by ozonolysis of alkenes, right? As we know, let us see what is the ozonolysis of alkenes, right? Let us see what is the ozonolysis of alkenes. Let me see if they have mentioned anything here. They have not mentioned anything here, right? So I will do that myself only, right? So that was your first reaction. That is your second reaction with copper, right? Third reaction, I am telling you, we are going to do this with the third reaction is the ozonolysis of alkenes. They are saying followed by zinc dust and water gives aldehydes and ketones, a mixture of both depending upon the situations. Now, why they have not shown it again and again? Because this is actually the repetition of things, right? So here ozonolysis of alkenes. For example, you have this alkene, right? This is H. Now, this is the alkene that you have. So, in this alkene, what will happen? What you will do, you will break this bond and apply double bond here, right? This is CH3, this is CH double bond O. So, instead we will write it as C. We will write it as C double bond O, and this is H. Similarly, here also, this is CH3. This is C double bond O, and this is your H. So basically what you had 2 aldehydes here, right? 2 aldehydes here. You will just break this bond and apply double bond O. That is how you will generate here, as we have generated aldehydes here, right? So depending upon what you have. For example, you had this kind of reaction where you had C double bond C. This is CH3. This is CH3, right? And this is your CH3. Now, to this what you will form? Now, this is a very, very important question. A lot of questions they ask from directly ozonolysis, right? In your PYQs, there is a trend that they ask you questions from ozonolysis, right? So, break this bond and attach a double bond here. So this will be CH3. This is carbon. Break this bond, attach double bond here. I have attached double bond here, and rest we have one H here. Plus what you will have here, this is C, this is double bond O, and this is CH3 here, and you have one CH3 here. Now two things you had here. One is your aldehyde, this is your aldehyde, and this is your ketone, and this is your ketone, and this is your ketone, right? That is for ozonolysis. Those who want to see this in detail, here I have just given you one trick that will be useful in your NEET exam. For NEET exam, you just need to know this trick only, right? If you want to go through the further mechanism, everything that I have covered that in your previous lectures, right? Where we have done, I think, hydrocarbons, we have covered this, right? Now next is by hydration of alkynes. Now by hydration of alkynes, they are saying that addition of water, this also have we done in hydrocarbons? Everybody in the chat box, have we done this in hydrocarbons or not? Have we done this in hydrocarbons or not? We have done this in hydrocarbons, right? With your mercuric sulfate, right? Mercuric sulfate and your H2SO4, right? You had the formation of ketones there. We have covered that in detail, isn't it? I have shown you the full mechanism there, right? So if you have not seen my hydrocarbons lecture, you can go through that lecture, and these reactions will be in detail, right? Now next is some of the new reactions here. Now let us see the new reactions here. New reactions, firstly they are talking about from acyl chloride. Now you just need to replace the Cl with the H here, right? You need to replace the Cl with H here, right? So basically this is C double bond O Cl. You need to replace this to C double bond O H. This is the thing that you need to do here. Now what you will do? You will do the hydrogenation in presence of PDBaSO4. Hydrogenation in presence of PDBaSO4. So your answer is acyl chloride is hydrogenated over catalyst palladium or barium, right? This reaction is called Rosenmund reaction. Very, very important reaction. Now, and this catalyst, when you use hydrogenation in presence of PD and you poison this by BSO4, by sulfur, this is called Lindlar's catalyst. This is called Lindlar's catalyst, right? What is this called? This is called Lindlar's catalyst. Okay, this is called Lindlar's catalyst, right? Very good. Next is from nitriles and esters, right? For example, you have RCN. For example, you have any ester, RCOOR. In that case, you will use Stephen's reaction. In Stephen's reaction, you will use a metal, right, in presence of HCl, right? So that metal can be tin or iron, right? Tin or iron we can use here. So here, nitriles are reduced to corresponding amines. Now this is your amine. What is amine? When you have C double bond N. When with carbon and nitrogen you have double bond, that is called imine, right? So corresponding amine with stannous chloride in the presence of hydrochloric acid, which only hydrolysis give corresponding. After hydrolysis, it will give us this NH will be reduced to C double bond O, right? So basically it will be RC double bond O and H, right? So this is called Stephen's reaction, right? Again, a very, very important reaction, right? These are the name. I told you in this full chapter we will talk about naming reactions, right? All are naming reactions only that we are going to repeat, right? And directly the questions are asked. Now alternatively, nitriles are selectively reduced by, this is called DIBAL, right? Now they are saying that if you want to, first is your naming reaction, that is Stephen's. right, where you are using stannous chloride in presence of HCl. But if we talk about the other thing, that is your RCN, so here what will happen? In this RCN, it will reduce to RCHO. This is the alternate method where we are using this diisobutyl aluminium hydride, right? Okay, di-iso, 2-isobutyl aluminium hydride, right? So here this CN is also reduced to this CHO. Now, very important thing here, that it is a selectively reduced. What is the selective reduction? Only CN to CHO. Other bonds here are not affected by it. You have a double bond. See, this is a very, very important reaction. Very, very directly this reaction also can be asked in your exam, right? Directly copy paste this reaction can be asked, right? Because here what students will do by using, they will be like very confused between should I reduce this double bond also, should I not reduce this double bond also. So this is a selective reducing agent. Stephan is not a selective reducing agent, right? So here you have this, and this double bond will stay intact, and this CN will be reduced to CHO. Now, similarly, esters are also reduced to aldehydes with the DIBAL, right? With DIBAL, we reduce esters to aldehydes. So, this is your ester. This thing will be fully reduced to hydrogen, right? With the help of DIBAL here, right? If you want to reduce esters to aldehydes. Now, this is also an important reaction, right? Also an important reaction. I can guarantee that from this chapter, question will be there only from your NCERT, right? Don't ignore NCERT for this chapter especially. Don't ignore NCERT, right? Okay. Now we have from hydrocarbons, right? We are talking about aromatic. Aromatic aldehydes are prepared from aromatic hydrocarbons by the following, right? Let us see how we prepare this. So first method is very, very important. That is your Etard's reaction, right? Use of chromyl chloride, right? Use of chromyl chloride. This chromyl chloride is basically red in color, that we will see in practical chemistry. Chromyl chloride oxidizes methyl group to chromium complex, which on hydrolysis give benzaldehyde, and this reaction is called Etard's reaction. Have we not written it anywhere? Wait a minute. It's not written anywhere. Chalo, I'll write it here. This is called Etard's reaction. Etard's reaction. No, in Etard's reaction, though, you have toluene, na? Let me see if they have used toluene or not. Yes, toluene there. This is called Etard's reaction. Okay, this is Etard's reaction. Etard's reaction. Very, very important reaction, right? Here also I am writing. It is called Etard's reaction. If your NCERT it is not mentioned, then mention it here in your NCERT. This is called Etard's reaction. Yes, where we use the reagent, the starting reactant is toluene here. You can't take any other reactant. It's toluene only. You can remember this by T, Etard, and this is toluene. From toluene, you will add chromyl chloride, that is red in color, right? Okay. Then we will add one non-polar solvent, and then this will form a chromium complex, which on further hydrolysis is converted into aldehyde, right? So this complex is CH and twice of this OCr, OHCl2. This is called chromium complex, and this is also important for you because in one of your previous year question, they can ask you that this will give you full reaction and they will erase this thing. They will erase this thing, right? They will erase this thing and they will ask you, they will erase this thing, wait a minute. They will erase this thing and they will ask you that what is this thing here? What is this complex that is formed? They will give you 4 options here. Then you will be like, ma'am, I thought, okay, I just have to remember the starting and the ending. No, you also have to remember what is this complex that is formed here, right? What is this complex that is formed here? This is also important because this so everybody know, this so everybody know. But students don't usually ignore this complex, right? You have to copy paste this chromium complex in your head, right? Okay. Next is, it's not a naming reaction, right? But yes, it's also a very important reaction where again we are forming from toluene, we are making benzaldehyde, but here the reagents are very different. The reagent is not chromyl chloride, rather what is the reagent? You are using CrO3 with acid anhydride at 273 to 283 Kelvin temperature. You will have the formation of this complex, and then this complex and that complex are very different. Okay, they can ask you this complex has high probability that they can ask you this. This has a very low probability, right? Okay, use of chromic oxide. Toluene or substituted toluene is converted to benzylidine. Wait a minute. Benzylidine. Yeah. Benzylidine diacetate. This is the thing they are talking about. This is your acetate group. This is called benzylidine diacetate. This is called benzylidine, right? Because it is mentioned in your NCERT, you also have to remember this name. What is this name? This is called benzylidine diacetate, right? On treating with chromium oxide in this, the benzylidine diacetate can be hydrolyzed to corresponding benzaldehyde with aqueous acid, right? Then the third reaction is, this was about from hydrocarbons, right? Then next is by, first was we are talking about was from toluene. Now we are talking by side chain chlorination followed by hydrolysis, right? You had this CH3. Whenever you are adding Cl2 and H mu, there is free radical mechanism, there is chlorination. This hydrogen will be substituted by Cl2, right? After the substitution, and this also is your PYQ. This also is your PYQ. This also is your PYQ, right? Etard's reaction is also your PYQ. Okay, that is also your PYQ. I am telling you, na, in aldehyde only you will see so many PYQs. Every single line there is PYQ, right? So this is your PYQ. In the PYQ, they have asked this thing. They have asked this thing. Students give least attention to what is this, right? They then get confused. Ma'am, was there CH2Cl? Was there CHCl2? What was formed? Benzyl chloride. That means CHCl2. And after hydrolysis, this Cl2 is replaced by oxygen, right? So here it is, what you have? CHCl2, not CH2Cl, not CCl3. No, it is CHCl2, right? Benzyl chloride. Side chain chlorination gives benzyl chloride, a very important compound, which on hydrolysis give benzaldehyde. This is commercial method of manufacture of benzaldehyde, right? Okay. Now, next is by Gatterman-Koch reaction, again important. This is also your PYQ, right? Okay. So, by Gatterman-Koch reaction, let us see by Gatterman-Koch reaction. Now, this is not from toluene. This is not from any other thing, right? This is not from hydrocarbons basically, right? This is from hydrocarbons, but this is not toluene. Here you have used benzene. You can't take anything else apart from benzene. The reaction is a named reaction, so it is specific that what will be the reactant. So, when benzene is reacted with, now basically what happens, this is just like Friedel-Crafts acylation only. In Friedel-Crafts acylation, what we do? We use, in Friedel-Crafts acylation, we use C double bond OCl. Now here I am writing one thing here. Here you want to make a complex like this, right? You want to make a complex like this. C double bond OH. That means what you need to have? You need to have C double bond OH. That means this should be the chloride, acid chloride that you should have, right? Because if you want to have CH3 here, then you will add CH3 here. Now tell me one thing, if you want to make CH3, just forget about this thing. If from benzene you want to make COCH3, you will do this thing or not? If from benzene you want to make COCH3, you want to do Friedel-Crafts acylation by adding CH3, COCl in presence of anhydrous AlCl3 or not? Hanji, tell me this thing firstly. Right, tell me this thing firstly. Yes. Yes, everybody. Only Roshni is there, oh what? Where are the other students? Are you sleepy or what? Sleeping, or you are celebrating Diwali side by side? Ma'am is sitting there on your chair and talking. You guys are, you guys are celebrating your Diwali, making rangoli side by side, eating fruit, eating sweets and all of that. Is it what happening? Huh? Chal. Now, this is the Friedel-Crafts acylation, right? Now, if instead of this CH3, I am saying here I want to have H. So here also I would want to have H, right? Problem is, this formyl chloride, this is called formyl chloride. Formyl chloride, this also they can ask you, not stable. That why can't you do this with the help of Friedel-Crafts acylation reaction? Because formyl chloride is not stable. That is why all the other things will be same. We will use anhydrous AlCl3 or CuCl. But instead of formyl chloride, we have used COHCl. Now this will immediately form formyl chloride, and that formyl chloride will immediately attach on this benzene ring. Because it is an unstable species, so we have to make this in the reaction itself. Right? That is why we have used COHCl. Right? That is why how many marks in this chapter from CBSE board and NEET? Okay. In NEET, you can expect around 3 to 4 or 5 questions also you can expect from this. Right? So, yes, this has a very high probability chapter. And if you talk about CBSE, again, it is one of the most important chapters, right? One of the most important chapters like electrochemistry, aldehyde, ketones, carboxylic acid. From here, directly they will ask you naming reactions. I can guarantee you on that, right? Okay, so now this is called a Gatterman-Koch reaction. Understand, Gatterman reaction is a different reaction. Gatterman-Koch reaction is a different reaction. You can remember this by Gatterman reaction. We used to move from, anybody remember? In Gatterman reaction, we used to form from disonium chloride to chlorobenzene or bromobenzene with the help of which thing? With the help of copper in presence of HCl, HBr, all of this. Right, copper in presence of HCl or HBr. According to that, you will have chloro or bromobenzene. That was your Gatterman reaction. That was not Gatterman-Koch reaction. Now, this is your Gatterman-Koch reaction, because you can remember this, the difference by, because it is Koch, so you can remember this by CHO. It has CHO, that means it is a formation of aldehyde is coming here. Right? Okay. Yes. Now, next is from acyl chloride, right? From acyl chloride. Now, this is by the treatment of Grignard reagent also, right? So, when you have Grignard reagent with CdCl2, you will have the formation of R2CD and MgHCl. Now, let us use this R2CD, right? With this cadmium chloride, right? When we react this acyl chloride with cadmium chloride, this will take out this Cl and place hydrogen there, alkyl chain there, because this is a alkyl chain, it does not have any hydrogen. is an alkyl chain there. That is why it will place R here, and hence you will have the formation of ketone, right? You will have the formation of ketone here, right? Ketones will be formed here. Next is from nitriles. Here we are talking about ketones, okay? From nitriles, a very, very important reaction. Again, it is a question of your PYQ only, right? This also has been asked so many times, right? This also has been asked so many times. So basically what we are doing, we know that this is CH2, C triple bond N. This is your partially positive, this is partially negative. In this also, this R part is your partially negative and Mg part is your partially positive. Now what will happen? A pi bond will break here, right? A pi bond will break here. I am writing it like this, okay? This is, I am taking this as R, okay? I am taking this as R. This is C. This is triple bond N, right? So what will happen? A pi bond will break here. Because a pi bond has break, so what will happen? Electrons will jump to this side. This is your partially negative, this is your partially positive. Just give me a minute. Just give me a minute. Okay, just give me a minute. So electrons will jump to this side, right? Electrons will jump to this side and this will be a positive charge. Now what will happen if I am taking this as R dash Mg X? If I am taking this as R triple bond Cn. So this R dash will attack on this side and MgX will attack on this side. So what will happen? Instead of this positive, you have the attachment of R dash here, and instead of this positive here, negative here, you will have the attachment of this MgX, which is positive, right? So this will be MgX here. I am making the generalized form here, right? Okay, so I am making the generalized form here. Now after this, what will happen? After hydrolysis, this thing, this whole thing will be converted to, after hydrolysis, this whole thing will be converted to double bond O, and hence you will have the formation of C. This is your R, this is your R dash, and this is double bond O, right? And hence you will have the formation of a ketone, right? And hence you will have the formation of a ketone, right? In all the Grignard reagent reactions, you will do the same thing. The same procedure is applied everywhere. One pi bond it will break, right? And the positive part will attach on the negative part will attach on the positive part. The negative part will attach on the positive, the negative part will attach on the positive part. The positive part will attach on the negative part. After the hydrolysis, you will have your desired product, right? Okay, everywhere. Grignard reagents are important, okay? Then from benzene or substituted benzene, right? Benzene or substituted benzene. Now, this is what? You have anhydrous AlCl3, you have RCuCl. This is nothing but Friedel-Crafts acylation reaction. As I told you, students, if you want to have here hydrogen, which is the reaction you will use? If you want to have here hydrogen, what is the reaction that you will use? Everybody in the chat box, what is the reaction that you will use if you want to have hydrogen here? If you want to have hydrogen here, then you will use Gatterman-Koch reaction, right? But if you don't want to have hydrogen, you want to have any other chain here, then simply you will use Friedel-Crafts acylation reaction, right? Anhydrous AlCl3. Here this will be your electrophile that will be formed, right? That will attack on this thing, right? In mechanism, we usually don't pick the arrow here. The arrow is from more electron density to less electron density, right? So here it will attach, and hence you will have the formation of your ketone, right? Hence you will have the formation of the ketone, right? Okay. Now let us talk about the physical and physical properties, right? Let us talk about the physical properties. Okay, students, everybody in the chat box. After physical properties, I will give you break, right? After physical properties, I will give you break of 10 minutes. Okay. Chalo. Now, the physical properties of aldehyde and ketones are described as follows, right? Aldehyde and ketones we are talking about, right? Now, methanol is a gas at room temperature. Ethanol is a volatile liquid, means it can volatile, right? It can form vapors here. Other aldehydes are liquid or solid at room temperature. The boiling point of aldehyde and ketones are higher than that of hydrocarbons, right? Why? This is important line. The boiling point of aldehyde and ketones are higher than that of corresponding hydrocarbons and ether of comparable molecular masses, right? What is the reason behind that? It is due to weaker molecular association in aldehyde and ketones arising out of dipole-dipole interactions, right? So what will happen? Here you will have C double bond O, right? This is, we know, partially positive, partially negative. Again, you have a carbonyl group where this is partially positive, partially negative. Because of this, in hydrocarbons, there is no as such thing as C double bond O, partially positive, partially negative. That is the reason in aldehyde and ketones, you will develop a van der Waals forces, interactions, right? That is the reason boiling point is slightly higher here. Boiling point is, it is due to the weaker molecular. Also, their boiling points are lower than that of alcohol of similar molecular masses. They are saying also their boiling points are lower than that of alcohols. Why? Because in alcohols, you have hydrogen bonding. In aldehyde ketones, you don't have hydrogen bonding, right? So, due to absence of intermolecular hydrogen bonding, the following compounds of molecular masses 1560 are ranked in order of increasing order. As you can see, they have ranked the boiling point order here, right? If you talk about hydrocarbon, it is 273. Then for methoxy, that means ether, right? This is for aldehyde. This is ketone, right? This is alcohol. So what you can see here, alcohol has maximum. They are not going to ask you the values. They will just ask you the boiling points, right? Order. Alcohol, then you have ketone, then you have aldehyde. They are approximately similar only. Then you have aldehyde, right? Then you have ether, right? Then least is your hydrocarbon, or you can say alkane. This is the order that you should remember for your exam, right? Order you should remember, right? Orders you should remember, not the exact table, right? Next is, now here they are talking about the carboxylic acid, right? No, they are not talking about carboxylic acid, they are talking about the solubility, right? So in water, what happens? This carbonyl, the oxygen of this carbonyl is partially negative, and the hydrogen, which is already attached to an electronegative atom, that will form a hydrogen bond between. Because of that, it has high solubility, right? But not that much as compared to alcohol, because alcohol, one molecule can form 4 hydrogen bonds. Here, one molecule can form only one hydrogen bond, right? So the lower members of aldehyde ketones such as methanol, ethanol, propanol are miscible with water in all proportions because they form hydrogen bond. But with increase in the chain, see, more is the alkyl chain here, bigger is the alkyl chain, difficult it will be to form a hydrogen bond here. Bigger is the alkyl chain here, difficult it is to form the hydrogen bond. The solubility of aldehyde and ketones decreases rapidly on increasing the length of alkyl chain. All aldehyde and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. The lower, they are saying aldehydes and ketones are fairly soluble in organic solvents, right, like benzene, this and that, right? And their solubility decreases rapidly or increasing the length because of steric factors, because of repulsion of big chains, right? The lower aldehyde have sharp pungent odors, right? Odor means the smell, right? the size of the molecule increases, the odor becomes less pungent, right? As the size of the molecule increases, because the odor is because of this carbonyl group, right? Okay, so now, in fact, many naturally occurring aldehydes and ketones are used in blending of perfumes and favorable agents. That's why we were saying, no, that in favorable agents, flavoring, where we want flavor, where we want very beautiful odor, right? So in candles also, in which produce very good smell, right? Fragrance, not smell, but fragrance. In those things, we use aldehydes and ketones because of the odor that they produce. Since now this is your chemical reactions, for that I will give you break. After that, we will do the chemical reactions, okay? Because this is a big chapter. We will do this today itself. My try is to complete this chapter today itself, right? But I don't want to rush. I don't want to, you know, make you in that position that your brain, you're like, ma'am, why you're torturing us on Diwali, right? So I don't want to do that with you, right? So I'll give you a break, take some rest, right? Take 10 minutes rest. After that, we will start with chemical properties and rest of the part, okay? Okay, students? Yes, very good. Okay, so I'll see you after the break, right? So the class is going to resume after 10 minutes, but before that, let me tell you that there are some very interesting offers going on for your Diwali, right? How many of you have already picked out these offers? Now the offer says that when we talk about DNA batch, right? See, if you want to have flashcards, pages, books, and combos, that is totally your choice what you want to have, right? But I'll tell you the offers that is only valid till today, right? Okay, because today the Diwali we have today, so until today or maybe tomorrow the offer will be valid. After that, it will not be valid, right? So DNA offer price, if you want to have just DNA, then you can have it on the 1499. That is the lowest price of DNA, right? 1499, right? But if you ask me, should I purchase only DNA batch? I would say no. I would say you should also, because right now is the time for practice. Right now is the time of revision. So my advice will be, you should go for combos here with DNA batch, right? So I'll show you the combos of DNA batch. For example, you want to have DNA batch with NYTS, that is year-long test series. In the next 6 months, you should also attempt some test series, right? So 25 tests will be given to you, and then the offer is 2499. That means you are getting 25 tests, right? Full test, subject-wide test. You are getting full mock test also, half syllabus test also, right? So that is for 2499 you are getting. And if you want to purchase only NYTS, that you are like, ma'am, I don't want to, I am already enrolled in DNA batch, ma'am, what to do? Then you should go for this NYTS for NEET, that is at wait a minute. I think there is some confusion here, because this price should be little bit lower than that, right? You can see that on the portal itself, right? That will be given in the portal itself. Now, next is, if you want to have DNA plus NYTS for NEET plus your books, right? That is, now in this case, what you can have, that will be at 5499, right? Books is for practice, for your notes. Then you have test series, then you have DNA. DNA is for your lectures, DPPs, mock test, then your test series, right? Then your practice questions. So I think this is a full-fledged combo that you should have, right? That is for 5499. Now, if you also want to have some flashcards, right? Quick flashcards. Now, flashcards, let me show you, right? Let me show you the flashcards here. Now, these are your basically flashcards that I was talking about, right? These are the flashcards that we are talking about. So, in this, what exactly happens? In just one sheet, you will have your full chapter summarized, right? In this one sheet. So, this is already made for you in a very colorful manner so that you are able to revise things very easily. That is a must have, right? You are an offline student, you are an online student, doesn't matter, because this thing is also not provided in offline institutes, right? Trust me on that, right? That's why I'm saying this is very, very important for all the students, whether you are enrolled to any batch, right? you are enrolled to any offline batch, any online batch, you must have these flashcards. That is for 1321. That is a must have thing, right, with you. Next is your, this is your this is your, wait a minute, Tejas books, right? So Tejas books also I'll show you. Wait a minute. Now, Tejas books are very nice books, right? Very amazing books. I have gone through them myself. They have full-fledged, information about short notes. These are basically your flashcards. In this, in a flash, you will see a full chapter written. But over here, you have your maybe 5 to 6 pages notes, right? Or you can say 10-page notes, right? Where you have everything is written in a summarized manner. All the important points are written in a summarized manner, right? And moreover, there are PYQs. There is a question related to that PYQs. There is NCERT based question which are very important for your NEET exam, right? So that is for 1600. Then you have DNA. Now, if you want to have DNA plus Tejas, that's also a very good offer, right? That is at 2999. Then if you want to have, wait a minute, I think with flashcards there is no combo. So if you want to ask me, what should I do? What is your advice? My advice, student, is that you should have, firstly to NYTS you should have, right? So I would really advise you to purchase this thing. That is DNA plus NYTS for NEET plus the books for your practice, right? These three things. Then this is the first thing, that is my advice. Okay? That is my advice. This is the first thing that you should have. Next is your flashcards. I think if you have these two things, these two combos, if you take flashcards and your DNA plus NYTS plus your practice books, then I think you don't need anything else, right? That is the best you can have for these 6 months, because you need revision. You will have flashcards, right? For that, you need practice. You will have NYTS, you will have mock tests, you will have our handwritten notes here, and also you will have that test series where you can give the test and see your report, right? And you will also have video solutions of these test series, right? That is made by your own teachers, right? Okay, so that is my advice to you. Avail this offer because that is only valid till now, right? Till today. After today, I don't know that will be valid or not, right? So avail this offer right away, because in this Diwali, on this Diwali, spend on something which is valuable. Spend on something instead of spending on crackers, of those things which are not useful to you. You're just polluting the environment by doing that, right? Instead of that, spend on something which is going to be your investment for your future, right? Okay, yes. Okay then students, now I will give you break, right? And the break is going to be, the class is going to resume. This is 12:17 at 12:30. 12:30 I am going to resume the class, right? Okay, so students, am I audible? Everybody in the chat box, am I audible? Yes. Break is over. Yes, Madhumati, Evening Star. Okay. So, let us see this. We were at 43rd slide, right? So, let us see that. 43rd slide, yes. So, now let us see that. First, it is going to be so students, the problem is that I have very high fever, right? Shall see. I think I won't be able to complete today's lecture. So let me see where I can take the part 2 of this chapter. I'm clearly not fine, right? So what are your thoughts on that? Yes. So I don't want to overload my health on myself on that. So that's why I'm thinking that to complete half of the chapter today and half of the chapter we will do in the next class. Okay? Yes. I'm not even sure if I have dengue or what. I'll see the doctor and see what problem I have. That's why I have to cancel the classes of last 2 days also, because I was not fine. Right? Yes. Yeah, so we will do half of it now, right? And other half, like I want to at least complete the chemical and physical properties of this one. And after that, like half of the chemical and physical properties, because they are also very, very large. I don't want to just complete this today because I know how important this chapter is, right? So I want to like give you a fluid everything in detail. Right? I don't want to just complete this chapter for the sake of completing this chapter. Right? That's not how I teach. Right? Yes. Okay. Chalo. Now, let us see, since aldehydes and ketones. Now, since aldehyde and ketones both possess the carbonyl function group, they undergo similar chemical reactions. And what are these chemical reactions? The chemical reactions are nucleophilic addition reaction, right? So, contrary to electrophilic addition reaction observed in alkenes, aldehydes, ketones undergo nucleophilic addition reaction. Can you tell me the reason behind that? This is C double bond O, right? Addition. Addition means break this double bond and to add something, right? So let us see how the nucleophilic addition reaction works, mechanism of nucleophilic addition reactions, right? So basically this is your group, that is C double bond O, this is A and this is B group. We know that this oxygen is more electronegative as compared to carbon. That is why the electron will jump to this position, is it? The electron will jump from pi bonds of this to oxygen, right? Now what will happen? There will be O negative. Now students, what will happen basically, as this is your C double bond O, this is A. Now the electrons are going to jump here. It is going to give us this bond, and this is O negative and this is your positive, right? This is negative and this is your positive. Now to this positive some nucleophile will attack, right? That is called basically nucleophilic addition reaction. This is how they work, right? And after addition, because it is a sp3 hybridized product, now it will form tetrahedral intermediate, right? And to this O negative, some positive part will attack. That means some electrophile will attack here, right? Why it is not called electrophilic reaction in the end? Because the first attack, the slowest step, in the slow step, the attack is of nucleophile. In the slowest step, the attack is by nucleophile. That is why slowest step is the rate determining step. That is what is called nucleophilic addition reaction. And in addition reaction, there is always breakage of a pi bond, right? So pi bond will break and you will have the formation of this addition product, right? And hence what we will say here, hence we are saying, hence we have A nucleophilic attack of electrophilic carbon to polar carbon, which is sp2 hybridized, the pi bonds will break and they will jump to the oxygen. This intermediate that has formed capture reaction to give electrically neutral product, because this is not an electrically neutral product. So it will capture some H positive or some electrophile to make electrically neutral product. The net result is addition of nucleophile and H positive across the carbon oxygen double bond. Now the same reaction we are going to see in so many ways, right? So first is the reactivity. Which is more reactive towards this reaction? Is ketone more reactive? This is a very, very important question, right? This is also your PYQ where they have asked you, right? This has also been asked in board exams as well. A full-fledged answer they ask in board exam, but in NEET they just directly ask you which is more reactive and what is the reason, or they can ask you in the assertion reasoning type of question. Now see this thing. Now aldehyde are generally more reactive than ketone. Now let us see why aldehyde are more reactive. So if I make one aldehyde here, that will be like this. This is R and this is H. If I make one ketone, that will be like this, C double bond O, and this is R and this is your R dash, right? This is your aldehyde and this is your ketone. Now see, this is very important to understand that this is your aldehyde. Aldehyde means, what is nucleophilic addition? We want to have partially positive here, right? How the rate of nucleophilic addition will be determined? Faster the attack of nucleophile, faster will be the rate. Faster the attack of nucleophile over here, faster will be the rate, because that is the slowest step. Now we have to see where the attack will be faster, which is more electron deficient. If this carbon is more electron deficient, attack will take place over here. If this is more electron deficient, attack will take place here. But now we know that there is something called inductive effect, and alkyl group shows plus I effect, right? They donate the electrons. They will donate the electrons here from one alkyl chain, but in ketone you are getting electrons from two alkyl chains. Now tell me one thing, somebody was very poor, right? Somebody was very poor, and here also that person was very poor. But now he is friends with one R group. So R group is giving him the money. So he is like, okay, I don't need money from someone else, right? No nucleophile can attack on me and break my pi bond here, right? Wait a minute, yes. Now here it is getting electrons from two alkyl groups. Now see, even here it is giving the electrons, even here it is giving the electron. One more thing I am writing here, your methanol. What is methanol? You have two hydrogens. It will have the maximum reactivity. Why? Because here you have no alkyl group to donate the electrons and decrease its nucleophilicity. But here one alkyl group is donating, so it has been decreased. Here two alkyl group is donating, it is further decreased. So firstly you have methanol. It will be methanol. Then you have aldehyde. Then you have ketone. Right? Methanol, then aldehyde, then ketone. And this was the first reason, is your electron donating effect. Second reason is your steric factor. Here it is easy for nucleophile to attack because hydrogen are attached. Here one alkyl group, which is a bigger group as compared to a hydrogen, that is attached. Alkyl group is bigger as compared to small atom, that is hydrogen. That is why more steric hindrance is here. Here you have two big alkyl groups, so even more steric hindrance is present. That is why it is difficult for nucleophile to attack here, right? So this is the reason. So let us see. First thing is, they are saying there are two factors. One is steric, other is electronic, right? Sterically, the presence of two relatively, that I have already told you. Electronically, they are talking about the inductive effect. Two alkyl groups reduce the electrophilicity of the, it's not nucleophilicity here, it's electrophilicity here. right? Electrophilicity means electron loving. I want an electron, something which is electron rich to attack, right? This carbon is saying, I am like deficient, I want electron to attack, right? So that is electrophilicity. Electrophilicity, this is also important thing. Sometimes they don't answer, they don't ask you that electron deficiency has decreased, they just say electrophilicity has decreased, right? More effective than the former, right? Next is some important examples of nucleophilic addition and nucleophilic addition elimination reaction. So let us see some of the very important examples, and you will see almost all these examples in your exams, right? You can pick out previous year questions. You will see almost all the examples here. If you talk about the first thing, that is addition of HCN, very important, how it reacts, right? So firstly, let us see the reaction, then only we will see the theory part, right? So firstly, what happens, HCN, in presence of a base, it will take out one H positive and it will form CN negative. Now, this is from the base. This is from the base, right? Then it will form CN negative. Now, this is your nucleophile. This is your nucleophile. Same way it is going to react. Same ditto copy paste, right? So, the electrons will jump here. This is your PYQ, right? This is very important, PYQ. Okay, cyanohydrin. What is formed? Cyanohydrin is formed, right? Very important PYQ, right? So here again, what will happen? Electron will jump here. This will be O negative, right? Electron will jump here. This will be O negative, and this is positive. So to this nucleophile will attack and it will form CN, and to this O negative you will have which? To this O negative, now you have this thing, CN and O negative. Right, that is your tetrahedral intermediate. To this, when you added H positive to this O negative, H positive is added, and hence you will have the formation of cyanohydrin. And this is a nucleophilic addition reaction. Here you don't have any elimination, you just have one addition, right? You just have one addition, right? Okay, very good. Yes, students, understood that or not? You just have addition. There is no elimination here. Right? This is very important, okay? Now, next is addition of sodium hydrogen sulfide. Okay, I forgot to tell you the theory part. Also, let us see the theory part, right? Aldehyde and ketones react with hydrogen cyanide to yield cyanohydrins. This reaction occurs very slowly with pure HCN. That is why it is catalyzed with base, right? So that we can take out H positive and CN negative can react there. The generated cyanide ion, being a stronger nucleophile, readily adds to the carbonyl compounds, right? So it is catalyzed in presence of base. That is an important point here, right? Yields corresponding cyanohydrin. Cyanohydrins are useful synthetic intermediates, right? Next is addition of sodium hydrogen sulfide. Sodium hydrogen sulfide adds to aldehydes and ketones to form addition product, right? What we do here, sodium hydrogen sulfide adds to aldehyde and ketone. Now let us see what is sodium hydrogen sulfide. That is your NaHSO4 sulfide, right? So NaHSO4, it will react with this. This is Na positive, this is HSO4 negative, right? Your nucleophile will be 3 negative, right? So here the electron will jump here. It will become CO positive here and negative here. To this positive, which will attack HSO3 will attack, and this will take part with the help of oxygen. It is not bonded to hydrogen. You can see the structure, oxygen is free, right? There is negative charge on the oxygen, right? Okay, it's like this. You have S double bond O, O negative, right? Here it's like this. This you have O negative here, right? So I'm writing here, this oxygen will attack here. This is SO2H, right? Now you have SO2H. Now what will happen? Again one H positive will attack here, and this will be replaced by H positive, right? Okay, okay. Now there is internal proton transfer. Wait a minute, internal proton transfer that I forgot to told you. This Na positive will attack here because it's a positive thing. Now there is internal proton transfer, right? There will be hydrogen here, there will be Na here. Internal proton transfer will take place here, right? Internal proton, this is a crystalline product, bisulfite addition product is formed here, right? Okay, now now let us see the theory part here. Let us see the theory part. Sodium hydrogen sulfide adds to aldehydes and ketones to form addition product. The position of equilibrium lies largely to the right position, right? To this, it is in the forward direction more than in the backward direction, right? Right direction for most aldehydes and to the left for most ketones, right? Now this is important point. Lies right hand side for most aldehyde. If you have a aldehyde here, right hand side, this thing will be formed more. If you have ketone here, then it will lie towards this side, right? For ketone, it will be this side, right? It will be on the left side, that means on the reactant side. Reason is again the same, due to the steric factors of ketone, the hydrogen, right? The hydrogen sulfide addition product in water soluble and can be converted back to original carbonyl compound. This thing they are saying, the hydrogen sulfide product, the product that we have formed here, hydrogen sulfide, that is a soluble product in water, right? So to this, therefore these are useful for separation and purification of aldehydes, right? So from this, I think one question has been asked to you regarding this step only, regarding this full paragraph. Directly they will not ask you this question, but they can confuse you with something like this, that if you have aldehyde, the equilibrium will shift towards forward direction. If you have ketone, equilibrium will shift towards backward direction. Because a product that is formed is soluble in water, that is the reason it will give carbonyl products, right? If you have ketones, right? Okay, now next thing is addition of alcohols. Now let us see the addition of alcohols. If you have alcohols, then what you should do? Now this is alcohol in HCl gas, right? So now this is your CHO, this is RC double bond O, and this is hydrogen. Electrons will jump here and it will form O negative, and this is your positive, and this is your H only here, yeah, this one. Now you have the addition of R-OH, right? You have the addition of R-OH. Now what will happen here? Now let us see what will happen here. Basically it will break like this, it will break like this, right? Because in the HCl gas it will break like this, it will give RO negative and H positive. H positive will attach here, H positive will attach here, and OR will attach here. So it will form something like this. So it will form something like this. Yes, it will form a product that is, this is OR. It will form, what just happened here? Yeah. It will form OR here, OR dash, right? So this hemiacetal product is formed. Now these two reactions, regarding the hemiacetal, regarding acetal, regarding ketal, three questions are asked to you. Regarding hemiacetal, regarding ketal, regarding acetal, three reactions, okay? So that is by addition of alcohol. Now, if you have 1 degree alcohol, right, that is ROH, right? You have directly 1 degree alcohol, ROH you will have the answer as hemiacetal, right? If you have excess of ROH, alcohol is in axis, right? You have one more R-OH. Now what will happen? Now again what will happen? This OH will be replaced by this OR dash, right? Hence you will have the formation of acetal, right? Hemiacetal is when to that you have only presence of one OR dash group. When you have two OR dash group, then you have, that is called acetal. Then that is called your acetal. Okay, that is called your acetal. Now next thing is, if you have added ethylene glycol. In ethylene, this is only possible in case of ethylene glycol. This is cyclic structure will be formed. How? This two bonds will break here, right? What will happen basically? What will happen basically? You can write it in this form. Wait a minute. This bond, you have OH, OH and HH here, right? So what you will do, one hydrogen from here, I want to write it in a different manner, right? So I'll write it on next page, right? That is a simpler way of understanding this. This is your R, this is your R, and this is your CH2, this is OH, this is CH2, this is OH, glycol. Now, how you should remember this? This oxygen and these two hydrogen, they will liberate, they will go as water and attach the remaining part. This is C, this is R, this is R, this is your one bond here, this is O, and CH2, CH2, one bond here. This is called your ketal, right? Okay, this is called your ketal. Now, these are very, very important. Directly the questions are asked regarding ketal. How to make ketal? Ketal is by ethylene glycol. How to make acetal? With an alcohol, not in excess. If you want to have in excess, then you will have the formation of acetal, if that is an excess, right? Okay. What is the difference between acetal and hemiacetal? Acetal, you can see here, to this carbon you have one alkyl chain, one hydrogen, but one OR group you have, one OH group you have. But in acetal, you have one OR group, other is also OR group, right? You have two OR groups, right? Two OR groups. But in hemiacetal, you have only one OR group and one is OH. That is the difference. Okay? And this is how we form ketal. And this is called ethylene glycol ketal. And if they ask you question regarding ketal, they will ask you this reaction, right? They will ask you this reaction. Now let us see the theory part here. Addition of alcohols. Aldehyde react with one equivalent. Now what they are saying? Aldehyde react with one equivalent of monohydric alcohol, which has one, very, very important, monohydric alcohol is used for hemiacetal or acetal. In the presence of dry hydrogen gas to yield alkoxy alcohol intermediate, and that is called your hemiacetal, known as hemiacetal, which further react with one more molecule to give gem dialkoxy compound known as acetal. Now this is also very important, right? What is this called? Gem dialkoxy. Now can you tell me why this is called gem dialkoxy? Because geminal and vicinal, there are two terms, geminal and vicinal. Geminal means when the carbon, when two same groups are attached on the same carbon, right? If two same groups are not attached on the same carbon, that is called vicinal, right? So geminal is, this is OR on the same carbon, that is called geminal dioxy, right? This is OR, right? Geminal dialkoxy. Alkoxy, and in alkyl chain you have oxygen also, so alkoxy, right? So we call it methoxy, ethoxy, right? So same in general you are saying alkoxy, right? That is also called acetal, very important. Ketones, if you want to make ketones, react with ethylene glycol. Now if you have the reaction of ketones with ethylene glycol, they form a product called ethylene glycol ketones, right? Dihydrogen chloride protonates. Now why dihydrogen chloride is used? Protonates the oxygen of carbonyl compounds and therefore increases the electrophilicity of carbonyl carbon. That means they are saying that what is the use of this dry HCl gas? What is the use of this dry HCl gas that you are using? Basically what it do, this carbon, it increases, because this oxygen now, this is partially negative, this is partially positive. Because of this HCl, it can give H positive. So what it will do, it will try to take away this pi electron. The pi bond will break here, right? That is how the electrophilicity of this carbon will increase. Basically, for any carbonyl compound, what we want to have, we want to increase the electrophilicity of this carbon. That is increased by adding HCl gas, right? Okay. This is also important. The reason, assertion, reasoning question, this can be asked. So I am telling you, all the lines are important in this chapter, right? Every single line is important in this chapter, right? Okay. The nucleophilic attack of ethylene glycol, acetyls and ketones are hydrolyzed with aqueous mineral acids to yield corresponding aldehyde ketones. Next is ammonia and its derivative. Mark it very, 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 very important. Very, very important. Now, why this is so important? Why this is so important, everybody? Why this is so important? Reason is in this chapter, see, here not only one, you have around 7-8 questions directly they can ask you, and this has been asked. You pick out PYQs, you can easily see 10 to 15 questions in your PYQs from this one reaction, right? From this one reaction, again, this is your PYQ. Right, I'll also tell you which is directly your PYQ. First, the amazing thing is this is so simple, such a simple reaction it is, right? So I'll tell you what is this simple reaction. I'll directly give you a trick on that, right? Trick also and to understand also. If you want to know about the trick, then this water, this oxygen and this H2, that will go out and you will have the formation of C double bond, and here you have nitrogen and this is your Z. Now Z will keep on changing according to the reaction. I told you, 7-8 reactions you will have from this one reaction. So Z will keep on changing according, you will just copy paste that Z in the product side also. Answer will be this carbonyl compound oxygen and hydrogen from this NH2, right? They will go out as water and you will have the formation of this thing, right? Okay. Now, how, ma'am, actually this is done? Now we know that exactly what happens here. This oxygen will go out here, right? And you will have the formation of C positive, O negative, right? Then to this, we know that amine, basically what kind of derivatives these are? These are basically all the derivatives of your amines, right? So exactly what they will do, you will have the formation of NHZ here. This is divided into two parts, NHZ and H, right? H will be attached here and NHZ will be attached here. NHZ will be attached here and H will be attached here, and rest of the two things are as it is. Now from here, water will be liberated. That means OH negative will be liberated from this side, and you will have one NH. You will have this thing, N, this is H, this is Z. This thing you will have, okay? So OH will be liberated from that side and H positive will go out from this side, and this double bond will shift here, and hence you will have the formation of C, this is 2, this is double bond, and this is NZ. Understood this thing? How it is done? From this, one OH is taken out, OH negative, and one H positive. And when H positive we are taking out, the bond that is between nitrogen and hydrogen, the two electrons will shift on this carbon and nitrogen, and hence you will have the formation of this pi bond here, right? Okay, but if you ask me, ma'am, do I need to understand this whole thing? You should definitely understand that what exactly is happening. Only then you will be able to do reactions in the exam, right? Otherwise, so cramming won't work in organic chemistry, right? So here, that is the main thing, but otherwise, if you just directly want to write down the reaction, most probably they will ask you directly the reaction. So this oxygen and this hydrogen, they will go and you will have the formation of C double bond NZ, right? Okay. So now let us see the compounds here. Now let us see, this chart is very, very important chart. This is a very important chart. All the names that are mentioned here are very important. Everything that is mentioned here is important for you. Every single thing that is mentioned here, right? So if you talk about this here, if I replace this Z by nitrogen, if I replace this Z by nitrogen, I will have NH3. Now, what I will have in the end? This will be NH2Z. And the answer should be C double bond O, C double bond N, Z. Z is this. You will have the formation of this thing. Isn't it? Isn't it? You just need to replace. The general thing is C double bond NZ. So just replace Z everywhere, right? Just replace Z everywhere, right? So this is NH2H. If you have amine, this is NH2, this is some Z here, that is my alkyl chain. My answer will be, you will replace this Z by R, right? So this is my answer. Now, this thing is called Schiff's base. The product that is formed here, C double bond O N, and there is one alkyl chain that is attached to it. It is called Schiff's base, and a very, very important thing, Schiff's base, right? They can ask you how you can make Schiff's base by using amine and any aldehyde or ketone, right? You can make Schiff's base, right? Then, for example, you have NH2OH. Now, the name here is NH2OH. This is called hydroxylamine, because to this amine you have substituted R with OH. So, this is called hydroxyl group, hydroxylamine. And it will make a very important compound, that is oxime, right? So, we know that this OH is your Z. This is my Z, this is my Z, this is my Z. So, on this Z, you will just replace it with OH and you will have the formation of C double bond O N OH. That is called your oxime. Again, a very important common name, right? Okay. Next is you will have NH2. This means you have NH2 and you have NH2. Now, this is called hydrazine, right? This compound is called hydrazine. They can ask you, hydrazine is reacted. What is the compound that is formed? The compound is hydrazone. Now, the names will be simple. The only different names are Schiff's base and oxime. And here also you have imine. Now, as I told you previously also, when you carbon and nitrogen have double bond, after that you have hydrogen, that is called imine, right? So, these are the three different names. Otherwise, the name you can guess it from the reactant itself. Right? Here you have hydrazine, here you have hydrazone. Here you have phenylhydrazine, here you have phenylhydrazone. Okay. So, in hydrazine, this is your Z part. So, this will be attached here. This is C double bond N and this is NH2. And now, this is called hydrazone. Now, if they are saying that instead of this hydrogen, I have replaced it with one phenyl group. Basically, the full answer is, here they have, this is your NH2, NH, this is, instead of this hydrogen, they have replaced it with one phenyl group. So, now this is called phenylhydrazine, because to this hydrazine, they have attached one phenyl group in place of hydrogen. Right, so that is called phenylhydrazine. Product will be, because this is my Z part, this is my Z part, this will be attached here, double bond N, NH, this is asked, this is very, very important, double bond N, NH and phenyl, this is called phenylhydrazone. Right? Yes, I know that, beta, I know that. Viewers are actually very disappointing. Because something, when you're getting something with like totally free of cost, no, then they are like, they take it for granted, right? But I can't do anything with that. All I have to do my work, right? I am doing my work. It's totally their choice if they want to be a very enthusiastic student or be a dull student who is just sitting there and just don't even talking or nothing. So I am so now already done with that, right? That's why I'd never say that do this, do that. Totally your choice, whatever you want to do, right? So now here it is. Now to this phenyl, this is a very, these two questions are asked mostly. This is also your PYQ. These two questions are basically asked. This one and this one. These two are, you will see that, right? And also one more question that is highly asked is this one, oxime, right? Okay, otherwise all of them are important. All of them are important, but some of them are repeatedly asked, right? So this is your, when you have on the second and fourth position, you have dinitro, and this is called 2,4-DNP, right? Dinitrohydrazine. Hydrazine to this hydrazine. So what is 2,4-DNP? Dinitrohydrazine. The hydrazine, you have one phenyl group. That means to this one hydrogen, you have phenyl group attached. 2,4-nitro means one you have nitro here, other you have nitro here, right? You have nitro here, you have nitro here. That is called your 2,4-dinitrophenylhydrazine, right? And now that is directly attached here. Now this is your Z part, right? And this will be converted here. This is C. What is the answer? What should be the answer? Answer should be C double bond N Z. So C double bond N. Then this is your full part Z, right? That you have mentioned here. Okay. Now what is semicarbazide? And to this 2,4-dinitrophenylhydrazine, you will have 2,4-dinitrophenylhydrazone. That's it. Here you have semicarbazide and here you will have semicarbazone, right? What is semicarbazide? Here you have NH, C double bond O. This is very important, very important. NH, C double bond O, NH2. This is your Z group. Now you will just replace this full group over here. This is C double bond N, NH, C double bond O, NH2. That is your semicarbazone. Okay. Thank you so much, Madhumati. Thank you so much. Thank you so much. Okay. Chalo. Now, I think that's it. Now, rest of the part we will do in the next class, because yes, half of the chapter we have completed, half of the chapter we are left with. But my health is not fine today. As you all know, I have fever. So, just pray for me that I should not have dengue. I'm really praying for that, because dengue is spreading throughout India. This is a season, right? So I'm just praying to God. I don't want to have bed rest. Okay, chalo. Now everybody, I'll be leaving, and again, happy Diwali, everyone. Happy Diwali. And do avail the offers that we are giving you. These are Diwali specific offers, right? Diwali Dhamaka. Again, I will repeat that. If you want to have DNA along with Tejas, that is for 2,999. There are different combos. If you want to have flashcards is a must have for every single student out there, right? Whether you are studying from Hi-Fi Institute, doesn't matter, you should purchase this flashcards. That I can guarantee you, this is a very rare thing to have, right? One of my favorite things, right? So this is a very interesting. I know that I am saying that, okay, students, make your own notes, right? Do make your own notes, but how beautifully these flashcards are made now. So beautifully they have been made with proper pictures and everything. It is very difficult for us to make these kinds of notes ourselves, right? So that is why I'm saying flashcards is a must to have for all the students, right? This to you must to have, must have thing. That is my recommendation to you, right? Next is, if you want to have practice, other things are, wait a minute, I have written must where? On flashcards, on Tejas I have written must. Tejas is also must, but firstly I will write for this one, flashcards. This is my number one priority, must have. This is for all the students. You have any other modules, you don't have any other modules, you are in offline, online, doesn't matter, you should have flashcards, right? That is my priority. That is what I would advise you. Second thing is, now it depends on what is your preparation. If your preparation is like, ma'am, my preparation is going okay, ma'am, I am seeing all your lectures, ma'am, I am a dropper, right? Ma'am, I don't want to see lectures, ma'am, I just want test series, I just want practice test, then I would advise you test series, right? Because test series, if you should have at least one test series, right? That is why I'm saying that next priority is going to be your test series, right? Next priority is going to be your test series. Then talking about the practice, that ma'am, I want to have practice. Then students, individually you have, wait a minute. Acha, I forgot to see this, hai na? I didn't see this. Ha. So if you want to have test series online, in that case it is 1999. If you want to have test series, like if you want us to deliver at your home, you want to have a proper hard copy of the test series, then it is for 2499, right? Okay, so that is totally your choice. According to the budget you can decide, right? If you're like, ma'am, 2499, I can't afford that, I am also buying flashcards, then what you do, then purchase this online one, right? Then you can purchase this online one, right? But you must have that, right? Either offline, either hard copy or soft copy. Hard copy I would prefer, because of eyes will strain, and in the exam also you will have hard copy. But otherwise, if you are like, ma'am, I want to like lower down my budget, then you can have online as well, right? Then next is, wait a minute, your books, hai na? This is the book. Now, for practice, this is the best book for practice questions, right? So that is my advice to you. You must have one book, right, for practice, Tejas, right? Then you must have flashcards. That is my advice to you, and one test series, that is NYTS, right? These three things are must have. Now for those students who want to have like, ma'am, I also want to see some of the lectures, then some of the topics I am weak in, ma'am, I also want to attend mock tests with different students, I also want to have DPPs, right? Ma'am, I also want to have your DNA batch short notes, your DNA batch handwritten notes, ma'am, I want to have that. Then what you need to do, you need to purchase this combo. Now combo are different combos we have. One is purely DNA batch. I would not advise you at this point that only purchase DNA batch, because otherwise now you are 6 months away, right? You need to practice. Then why only to see just DNA batch, right? Because you will purchase DNA, after that you will purchase test series, and you will purchase stages, different things. Why not to purchase combo directly, so that you can have discount offer as well, right? So this is I would advise you, if you want to have all of these things, then DNA plus NYTS, you can individually purchase stages and flashcards, right? Or you can also have, this is my favorite combo here, right? So here you have DNA, NYTS and your modules, right? 3 things you have here, right? My advice to you is purchase this combo offer, right? Purchase this combo offer. It's an excellent offer. That is just for 5499, right? In 5499, who is giving you everything here? DNA plus test series plus practice books with the solutions also, right? And these test series are with the video solutions, right? With your own teachers, right? Next is flashcards, right? If you want to invest something on Diwali, invest on flashcards and invest on this 3 combo. That is my favorite thing. If I would have been at your place, I could have purchased this thing and flashcards. Because with DNA, I could have everything. My full syllabus, if I'm weak in any chapter, yes, everything is there. Right? You can ask the DNA batch students as well. Everything they have, right? They are fully satisfied with the batch. They are so happy with the batch, right? Classes are going on continuously. It's not that batch, ki online batch, teachers are on leave every day. No, strictly to us, right? It is strictly, if I want to take a leave, I have to mail it 1 to 10 days before. Otherwise, I can only have emergency leave, and that is not applied everywhere. And that is not like I can have 5 emergency leave. Maybe once in a month I can have 1. I haven't taken even 1 emergency leave. Even when I am sick, I'll go there and teach the students, because full dedication by the teachers, it is there in the batch, right? So I would advise you to have DNA so that everything you have missed on, you can have that, right? Yes, it is full test series. You have subject wise test, chemistry, bio, physics. You have full syllabus mock test, you have half syllabus mock test, right? Everything is there, right? So you have 25 total tests you have with video solutions, right? It's not like you will just, okay, answer sheet, we will give you just answer booklet. No, video solutions are there, right? Okay, next is your concise theory with concepts, everything. PYQs you will have in the books, right? You will have solved example, 20,000 plus problems with solutions. And if you're not even sufficient with that, in DNA batch, we are providing you 150 plus books. So you can also have your question practice from that. But my advice is, firstly, go through the DPPs of DNA, right? Then after that, you should attempt at least one test every week, right? And mock tests are already going on in the DNA batch, right? And then you should practice your own difficult topics from these books, right? Then once you have practiced this, then only go to that 150 plus books. Your priority should be practice from this book, right? Okay, because this is specially designed for you, right? Then there is flashcards. As I've already told you, flashcard is it is the must to have. It is, if you are a topper, you're already scoring 720, you must have. If you're right now at that point where you're scoring 500, maybe 400, you must have that, right? It is for all the students applied. Whether anywhere you are studying from, this is applicable to you. Vedantu flashcards is one of my most favorite things. I've never seen something like that, right? Which so beautifully they have, mentioned everything. Being a chemistry teacher, it has my heart. It has my heart, right? Okay, chalo. Okay then, students, bye-bye. Take care. See you all in the next class. And again, happy Diwali. Okay, bye-bye. Take care. See you all in the next class. And when I will take aldehyde, ketones and carboxylic acid part 2, I will update you that on Sunday or maybe on Monday. I will update you on that. Okay? Okay then, bye-bye. Take care. See you all in the next class. Bye-bye.